Okay, memory. Memory is the ability to store and to retrieve information. And memory is formed through synaptic connections. So let's call it an engram. So an engram is the physical neuronal pathway for memory of memories. Okay, so for example, you may have one neuron here, synapses with this neuron, which snaps with this neuron. You may have one here that snaps here, and this circuit of neurons will be the memory for your name. Okay, so this may be your name engram, for example. Okay, so engrams are physical synapses between neurons that lay down your memory physically. And engrams can be modified. You can get rid of neurons in the engram, so then that memory is probably lost forever. Or you can add neurons, synapses, to the synapses to enhance the local potentials that will then create an actual potential to then fire and turn on the engram to bring the memory back. So engrams are physical things. And so these synapses in your engrams can be modified. So something that we call synaptic plasticity is the ability to modify synapses. Okay? Some synapses you can add to synapses, add new connections. You may also remove connections, remove synapses. Your dendrites can be removed, deleted, reobtaken, or pulled back in on a matter of hours, not weeks or months. Very quickly, you can really modify the synapses to enhance the memory or to erase the memory. Okay, so due to this plasticity, this is how we're able to learn new things. If the brain was hardwired, we couldn't acquire new information, but so it's able to move it around, fix the brain, change it around. Okay. All right, so some types of memories. Types of memories. You have your immediate memory, which is used for, it can last for seconds, and used for, especially in reading, to read a sentence, you want to hold a thought, a memory for a few seconds to be able to interpret the sentence at the end of the sentence. Okay, so it's a very, very quick memory, immediate memory. Just on the go is not meant to be used after just a few seconds. Okay, so then you have your short-term memory. Short-term memory. This kind of memory can last from seconds to hours. Okay. For example, you could hear a lecture today I give you, and you go home, and an hour later you can still recall the lecture. That's short-term memory. Then a week later, the memory is gone, which means it was still a short-term memory. It wasn't laid on properly in the long-term state, so it's gone from you. So it's really, again, a memory that's usable, meant to be used in the short term, and allow for functions that way. One form of short-term memory is what we call working memory. This kind of memory is like a task memory. Okay, you use it during a task. Your good example would be you're painting, or you're cutting something, or you're doing something. While you're doing it, you want to remember what you did 5 minutes ago, or 10 minutes ago. So it can last, for an hour or two. It's almost like a procedural memory. You're doing it. You're creating, those memory traces that can last as long as you're involved in a task. They're all firing together. And then your short-term memory, some ways that we have to allow for the short-term memory to last for hours or minutes to hours, are two main ways. So here, for example, ways to make memories last, especially in the short-term sense. Okay? There's something called Tetanic Stimulation. So here, if you have, say you have snaps, here's your neuron, here's another neuron here. Okay? So in this case, what we call tetanic stimulation. Tetanic means very fast, okay? Almost at max frequency. So in this stimulation, you're rapidly sending out action potentials down the axon terminal, and that will cause a massive influx of calcium. So each time the AP arrives, calcium gets pushed into the cell, into the knob. And so now you have a high amount of calcium inside. Sorry, you have high levels of calcium inside the knobs, which will cause you then to release more NTs. Because the amount of NTs that you release is a bit proportional to the amount of calcium that comes in. Okay, so tetany causes you to get more CA in, and that increased CA causes more NTs, which leads to more or bigger LPs, which can then drive you to have more action potentials, or increase the likelihood of having an action potential, and therefore this synapse is alive. It's moving down to the next synapse. Okay? So you can modify all the synapses in an engram that way, such that they are more likely to fire. So that's tetanic stimulation. That can be used to remember something maybe 30 minutes to an hour. Okay, so you can still short-term memory. Then even may have short-term memory that can last for hours, right? So let's say a short-term memory that lasts hours. Maybe due to a related phenomenon that we call post-tetanic stimulation, where the original tetany that you had, this original event, still has left behind a higher level of calcium. It has not all been pushed out by your pumps yet. So it's still in the knob, and a few hours later, when a normal amount of APs arrive, you still bring calcium in from the outside, but that calcium plus the one that's already there from the previous tetany will again lead to an enhanced amount of local potentials, which will eventually trigger action potentials. So those are two ways that help a memory to hang around longer than normal. Okay. Tetany, tetanic stimulation, as well as post-tetanic stimulation. And that's memory. Let's do long-term memory. So long-term memory these memories last a lifetime. Okay, lifetime memories. And they can be of two types. You have your memories that you can do but not verbalize, call these your procedural memories, like riding a bike, tying a shoelace, okay? You can't really hard to verbalize, hard to explain how you do it, but you can do it. Versus the memory that we call declarative memory. This memory, you can verbalize, speak it, say it, describe it. And your declarative memory comes in two types. So you have declarative memories can be semantic memories, meaning memories of facts about the world. Okay? This factual knowledge. Things like how far the sun is from the earth, right? How many planets there are in our solar system. Those are factual knowledge about just things which aren't really personal to you. Okay? And so this kind of knowledge is acquired through technique. You read it, you try to create some kind of saying to memorize it, and you repeat it. Okay, so it's done through some technical way, some study skill method to get it in. Whereas you have your episodic memories. These are memories that tend to be personal, from personal experience. That can happen once and they stay on forever. The birth of a child, wedding day, solar eclipse, 9/11. These things stick in your mind because they imprint on you personally, okay? And they just have to happen once. And it's such an imprinted experience that you can't forget it. So we call those they happen in an episode. It's called those your episodic memories. Okay, so these two forms can be described, so they can be declared, but they refer to different types of memories though. Now, one method that the brain uses to store your long-term memory is something called long-term potentiation. Long-term potentiation, LTP, is a technique that helps to enhance the synapse. So here's a case where you have, say, a neuron here, and here you have one type of receptor, call it a AMPA, or I forgot what it's called. Okay, I forgot the term for that one. But so let's say this is one type of receptor. So type 1, it's a type 1 receptor, call that one. And something happens that will trigger or change the amount of receptors on this neuron. So now you can modify the synapse such that you get a situation where you have two types of receptors. So you have type 1 receptor and a type 2 receptor now. So now when the entities come out from here, okay, they have more ion channels to open, more light-gated channels to open to create more influx of ions, to create a bigger local potential that will again trigger an actual potential to wake up the synapse. That's called long-term potentiation, where this is done, sits there and waits for years to fire and bring the memory back. There's also what we call memory loss, amnesia. So amnesia is the loss of long-term declarative memory. Loss of long-term memory that is declarative. Okay. Memory, not procedural memory. And it can happen in two ways. You can have anterograde amnesia, where say you suffer a traumatic brain injury, and then you can't form new memories, new long-term memories after the event, after the injury. Or you may have the other way, where it's called retrograde amnesia, where you can't recall old memories. Can't recall old memories from before the event. And people who suffer from either forms of this amnesia can still drive a car. So the procedural memory tends to still stay intact, but the declarative memories are affected by amnesia. Now, to wind this down, we can talk about storage of memory. Okay. So once the event happens and you're trying to lay down the memory, there's an area of the brain called the hippocampus. The hippocampus is believed to be involved in what's called consolidating the memory. It kind of sends the memory to the proper cortical areas of the brain for it to be stored permanently. So without this, the memory doesn't get sent to its proper destination and doesn't get stored, and you can't form the memory. So it's called a consolidative memory. It's not stored here, it just helps to relay to where it's stored eventually. And then for storage of the memory, the nature of the memory will determine where it's stored. Okay, so again, you have the temporal lobe will store your vocab, your dictionary, and faces. That's where you go to get to recall those things. Your prefrontal cortex will store your roles, again, your social roles. You know, who you are, who you want to be. Your cerebellum will store your movement memories. Okay, what do I call it here? Your motor memories, things you do with the muscles. Hit a bat, swing a bat, play the piano, stored there in the cerebellum. And your amygdala helps to store your emotional memories. Okay, so here we go. And of course, we have other areas, but this is what we've been able to ascertain at this moment. I'm sure there's more to come. Okay, all right, so that's memory. We'll pause there and then we'll pick up shortly.